Okay, so good morning, everyone. Today we are going to simulate a transistor level implementation of two input OR gate using custom compiler in Synopsys tool. So let's begin with the design first. Okay, so our design equation is as follows. So we have to implement a two input OR gate. So let's say that Y is my output and A and B are my two inputs. So we have to implement the following expression using static CMOS logic. Using static CMOS logic. Okay. So what we will do first is, first, as a first step, we will implement a NOR gate. Okay. We will implement a NOR gate, a two input NOR gate to be precise. So we can write NOR 2 gate using static CMOS logic. Okay. Whose expression will be Y is equal to A plus B bar. And then we can connect an inverter at the output to make it a OR gate. Okay. So now let's start with the design. So since we are using a static CMOS logic, we will start with the pull down block. Now pull down block consists of NMOS transistors. So since it is a NOR logic, your pull down block will consist of NMOS transistors which are in parallel. Fine. So let me draw them here. I'll use a 3-terminal symbol. Okay. So this is my input A over here. I can mark it input A. And this is my input B. Fine. So these are my two NMOS transistors which are connected in parallel and which will make up the pull down network. Okay. Now in the pull up network, we will have two PMOS transistors which are connected in series. So we'll start by drawing the two PMOS transistors which are connected in series. Okay. This is B. So I'll connect it, join them with a wire. And this is A. Okay. And then the source terminal of this PMOS transistor will be connected to VDD, and the drain terminal of this will be connected over here. Okay. And we can take the output. I am using orange color to take the output from. So this is my output. Okay. Y, right? And Y is equal to, over here we can write Y will be equal to A plus B bar. So this logic will be going to will give you a NOR gate. Now, if I have to connect, if I have to, design a OR gate, I have to connect an inverter. So inverter will be like this. So this is the symbolic representation of an inverter. But in actuality, we will be using a transistor. We are drawing a transistor level implementation. So instead of drawing the inverter, we will be drawing another CMOS inverter over here at the output, right? So let me go over here and take some wire out. Yeah. And let's draw the CMOS inverter now. Yeah. So for the CMOS inverter, we will have NMOS at the pull-up network. So let me draw a NMOS transistor and a PMOS at the pull-up network and an NMOS at the pull-down network. We join the connections quickly, and both the gate terminals will be connected over here. And here we'll have VDD. The source terminal of PMOS will be connected to VDD, and here we will have ground. Source terminal of NMOS will be connected to the ground, and here is my output. and this output will give you y is equal to a plus b, because we are added an inverter, and inverter will give, if you apply a bar, it will give a at the output, right? So this is the implementation of transistor level implementation of a OR gate. Fine. So this is what we have to implement in our Synopsys tool. So we will see that shortly now. So let's open the Synopsys tool. So over here we will type custom compiler, custom underscore compiler space and then press enter. The Synopsys tool will open. Okay, so now let me maximize this and let's start building our design. So the custom compiler is open now in Synopsys tool. So we'll go to the library manager to create the cell libraries. So over here we see the library manager. So to create a new library, we have to right click over here and click on new, and you can give the name. I'm writing ISD underscore or 2. It's a 2 input OR gate, and yeah. So here you can select the text file as 32 nanometer or 22 nanometer PDK. So we can select as it is and then click on OK. Fine. So if you click on OK, your library is created, ISD underscore or 2. It's for a 2 input NOR gate. Then we can add your cells over here. So you can select the library, right? You can go to cells and then we'll start creating a new cell so that we can make a schematic in it. So I'll right click over here, click on the new, and then I can name the cell as ISD underscore or 2 gate. Okay, and then I'll click on OK. Yeah, so a cell is created now. Now there is a no view provided over here. So we will click over here. We'll right click over here and then again we'll click on new, and then it will ask for the view name. So here we will be viewing the schematic. So click on the schematic. Editor will be schematic editor itself, and then click on OK. Yeah. So the moment you click on OK, your schematic screen will appear. So this is the schematic, editor for the Synopsys tool. That is your custom compiler. Now we have to start creating a circuit. Which circuit we are talking about? We are talking about a OR gate. So for OR gate, you will have to create a NOR gate followed by a CMOS inverter. So this is the circuit which we will be implementing in the custom compiler. So let's continue further. So to create an instances, to add the transistors, we have to add instances. So from here, we can click over here, right? And here you have to select the library. So from here, we can select the library PDK 3228 nanometer. And you can start typing over here NMOS 4, NMOS 480. Okay, you can select this transistor NMOS 480. So here the length is 30 nanometer and the width is around 100 nanometer. So let it be by default. So I can drag it over here onto the screen. And if I want more than one, this is your NMOS, right? So NMOS will be required over here in parallel. So I can have one, click over here. I can have another like this. And I can have a third one also for the CMOS inverter. So here it is. So I've added the three instances for the NMOS transistor. So I can scroll down a little bit. I mean, I can click on this and I can go down little. Yeah. So now that I have added the NMOS transistors, now it's time to add the PMOS transistor. Again, I'll go to the add instances, and here instead of NMOS 4T, 4 terminal, 4T stands for 4 terminal, I will type over here PMOS. Okay, so I'll select PMOS 4 terminal device. Let the length be 30 nanometer and the width be 100 nanometer. We'll keep it by default. So now we will add it over here, right? We'll have to add one over here and one more at the top, because we are building up the uh, and we will add one more here for a CMOS inverter. Okay, and now one more instance will come. We can press escape to go out of it. Okay, so now that my entire circuit is created, now it's time to join them together. I can zoom out a little. So zoom out will be very much. So I can press this to full screen, fit the screen. So here it is. Now we have to connect them together with wires, right? So let's start connecting them together with the wire. So before that, I would like to move this a little down. So what I will do, I'll click over here. This is the, you know, the command for moving. So I'll select this. I'll make it a box, and this I will move it down slightly. Yeah, I think this position is okay. And now I have to add the wires. So for the wires, you have to click over here, and wherever you want to add the wire, you can add it like this and like this. Okay, so similarly I will be connecting all the wires and connecting the circuit. So let's do that. So in this way we connect all the connections. So let's have a look at it. So your over here the PMOS input is your connected to the, I mean the gate terminal of the PMOS is connected to the NMOS. Your this PMOS gate terminal is connected to this PMOS gate terminal. Okay, I think this connection is slightly wrong. So what I have to do is I have to right click over here and delete that connection. Actually, this should go to the ground. So we'll select a wire from here and add it to the ground. Yeah. So this will complete the proper connection. This is the another input going to the gate terminal. Then the body terminal of PMOS are connected to the VDD supply, and the substrate terminal or the body terminal for NMOS are connected to the ground. So this is the same design as we have seen over here. So here the two PMOS transistors are in series, two NMOS are in parallel in the pull down, and here we have a CMOS inverter. So same is the design as shown over here. We have two PMOS transistors in series, and then two NMOS transistors in parallel in the pull down, and then we have a CMOS inverter, right? Now next step is to add the inputs, I mean the pins, right? So we'll click on the pin, we'll bring it near here, and we can name the pin as, I'll name it as input 1. Okay, and this pin should be type input. So here I can select it's already input, so it's fine. Here I can define it like this. I can add another pin over here. Okay, I name it as input 2, and I'll add it over here like this. Again, it's an input type, so I will add it as it is. Now we require another pin over here, but this pin should be output type. So I'll select output, and I'll name this pin as out. Okay, and I'll add it like this over here. Okay, so I place this pin. Now I can add the power pins also. So similarly, I can add the power pins. Let me just escape and slightly scroll down. Okay, with the help of this. Yeah, so now I'll add the power pin over here. So I'll go to the pin, and this pin also will be input pin because we are inputting the DC supply. So let me go to the input, and let me add that pin as VDD. Okay, and I add that pin. Orientation I can change it. I can click on R. Okay, if I click on R, it automatically the orientation changes, and I can add that pin over here. Okay, fine. Now let me zoom out a little, and similarly I have to add the pin down below for the ground or the VSS supply, right? So I'll scroll down a little. Yeah. So I'll add this pin over here now. Again, this will be an input type pin, and I'll rotate it, and the name of the pin will be VSS. Okay, it's the pin for the ground, and I've added the pins. Okay, now if I go over here, so all the pins are added. Now I will be joining them with a wire. So let me just zoom out a little. So this is the way I will join them, connect them with a wire. So let me connect all the pins so that I can a little bit fast forward the video. So now I've added all the pin connections. This is input 1, input 2, this is VSS, this is output, and this is VDD. Now it's very important to save your design. So you click on save, and there is something called as save and check. So save and check will give you if there are any warnings in your design. So you can go to console and you can check. So here you see no rule violations found in the schematic. Okay. And once you read the message that marking of the design is complete, and then you can safely go in the next step. So in this step, we have created the schematic for a transistor level implementation of a OR gate using static CMOS logic. Now, next step is to create a symbol. So for creating a symbol, you will go to design, you will go to new view cell, and you will go to from view cell. So you'll go over here, there will be an option of a symbol. So you click on OK. So moment you click on OK, you will get a symbol of your schematic, right? So in this symbol, we have to just delete this unnecessary names which have been given over here. So let me quickly do that. So I have deleted the names over here, inside also. And let me slightly move this slightly, up. I'll zoom out a little. I'll select the move button and I slightly move it up here. Yeah. And now I can safely, okay. Okay, fine. So now I can put it to full screen. So this is the symbol which I get after creating the schematic. This was the schematic, and this tool has enabled me to create a symbol. So this symbol will have 2 input pins, 1 output pin, and 2 supply pins. And that is exactly what we are getting over here. Okay. So we can adjust the symbol in such a manner that we have 2 input pins over here. Here already are 2 pins over here, right? I can readjust the symbol, right? So right now it's already symmetric. I can change the shape of the symbol from here, right? I can select it to any shape. I can increase or decrease it as I show it to you. Wait, let me just show it to you once. Okay, see, you can increase that, decrease that. You can create a an OR gate like a symbol. So you can do that. Right now, I will be adjusting in a manner which is suitable, right? So let me do that. Okay, I have adjusted the pins. This is VDD pin, this is VSS pin, this is my output, and this is my input 1, input 2, right? And now there is the CDS name. I'll right click over here and I can name this now as ISD underscore or 2 underscore gate. So save it in the same name as you have given to your schematic. And then I can drag this at the center of the symbol. It's very important to do this step, or else the symbol will not be recognized that this is the schematic which we have taken. Okay, fine. So after doing that, you can save the symbol. Yeah, so your symbol is saved without any problem. And now you can close this. Now you can close the schematic also. Now you go to the library manager. Now we have to create a test bench for our schematic. So I'll right click over here, click on new. I'll type name as ISD underscore, ISD is the name, my name, and OR gate 2. It's a 2 input OR gate, right? And then I can name it as test bench, TB. And then I'll click on OK. Fine. A new cell is created. Let me create the view for it. So for this view, I will be creating new, and the view will be schematic. Okay, and it will let the schematic editor get open. So the moment I click on it, the schematic editor gets open. Now from here, I will add the instances. I have to select the library. So I have to use that symbol which we have used. So this already this thing is created. So I'll click over here, and then I'll add that cell from here. Okay, this is the symbol which we have created. So this is getting dragged onto the screen like this. See, so I'll paste it and then escape. So as you can see, a symbol is appearing onto the schematic directly. This is representing the schematic for the OR gate, two input OR gate. Now next is I have to add the supply. Okay, I have to add the supply and vpulse. So for that, I'll click on add instance, and from here for that I have to go to the analog library, and in analog library I have to type VDC. Let me type small VDC. Supply VDC I have to select. Okay, and then I can give the voltage, DC voltage for this. 28 nanometer and 32 nanometer PTK is around 1.05 volt. Okay, so this power supply I will add it over here. Yeah. Next thing which I want to add is ground. So I'll type GND ground. So some grounds will be required for this. Let me add those grounds. Let me zoom out a little. Okay, I'll be requiring a ground for the supply. I'll add one here, and I'll add the ground for the VSS, and then I also require two grounds separately for the two inputs. Okay, fine. So the ground thing is over. Now I will be adding a vpulse. vpulse. Okay, let us see. I think the letter is all small. vpulse. Okay, so the vpulse is selected now. Yeah, so we have to define the DC voltage. DC voltage will be 0. V voltage 1 will be 0. Voltage 2 will be, let me give it as 1.05, and then delay time will be 0. Rise time will be 0.1 microseconds. Fall time will be 0.1 microseconds. Pulse width I can give it as, okay, here I will delete one extra U is added. 0.1 microseconds. Pulse width will be 5 microseconds, and the period let it be 10 microseconds. Okay, fine. So this pulse has been added. So this will be going as, if I rotate it, yeah, this will be going as input 1 over here. Okay, so that, okay, I have to add the pulse again. Quickly, it is 0 to 1.05. It will be like a revision, and rise time will be 0.1 micro. Fall time will be 0.1 micro. Pulse width will be 5 microseconds. Time period will be around 10 microseconds. Okay, so this pulse I will be adding it over here. Okay, next I want to add another pulse, but here the voltage will be slightly different, so I'll be doing that later. But first, let me deal with this pulse over here, which is connected. So I right click over here and rotate right. Okay, I have to rotate left. Let me do that. Yeah, so that I can add it over here. And now I'll add another pulse. And here the voltage will be 0 to 1.05. There will be a delay time. I'll give it a delay time as 1 microseconds. Rise time will be 0.1 microseconds. Fall time will be 0.1 microseconds. Pulse width will be 5 microseconds and period will be around 10 microseconds. Fine. So the second pulse, I will add it over here. Okay, I can rotate it. Yeah, here I'll add it. Okay, fine. I'll escape. Yeah. So now that I've added my 2 pulses and the supply, now it's time to check the output. Fine. So let me join them, connect them together with the wires quickly. So I'll use the wire and connect them. Okay, let me fast forward the connections. Okay, so now all the connections are done. At the output, we have loaded with a capacitive load of 1 picofarad, and we have connected the 2 pulses over here, and VDD and ground. VDD has been given 1.05 volt, right? And now we are ready to simulate, correct? So also click on check and save. So it will check for any design errors. So there are right now, let me check in the console. No rule violations are found and the marking of the design is completed. So you can safely move forward from this step. Okay. So your symbol creation, and we have created a schematic first, then we created a symbol, and now using that symbol, we are applying the inputs. So this is simulation for a 2 input OR gate. Now for simulation, let's proceed forward. Okay, so next, after saving this, we can close this schematic and then go to the library manager. And from here, actually, we'll open it slightly. And then we'll go to the tool. And then we'll click on the Primewave. So Primewave, with the help of Primewave, we'll simulate the test bench, which we have created. So it will take around 5 to 10 seconds, depending upon your processor speed, to open up the test bench. Yeah. So now we have to add a model file. So double click on the model file. So it will ask for the part. So we have to give a part over here. So what we will do is, we'll once again go to the library. Okay. From here, we'll go to the library manager. And here, this is the library which we want to add the part, right? So I'll right click and copy the part from here. Okay. So once I've copied the part, I'll again go over here. And here I have to add the model files, right? So I'll add this part from there. Okay. So now we have to click on the model file. So again, we have to search for the part. So in this, we have to go to, so we have added the model file. Now we have to go slightly up. We have to go to HSpice and select this 32 nanometer library. Yeah. After we have added, we have to add a section. So you have to type TT and select it. And then click on OK. So now we have selected the model file, right? And now we have to go to analysis and select on a transient analysis. Start time will be 0. Time step, we can give it around 1 microsecond. and stop time we can give it around 20 microseconds. Okay, and then click on OK. So next is we have to add the expressions. So we'll double click over here and then click on this symbol, right? It will pick from the design. So what all things we have to add? Actually, we have to do one thing before that. We have to add the labels, right? So before going over here, I'll go to the schematic once and I'll add the label. So add the label on the wire. We'll right click over it, click on the add a wire name. So I'll add the wire name as IN1, input 1. Here I'll also right click. I'll add the wire name as input 2. And here also at the output, I'll add the wire name as out. Okay, keep the wire name and the symbol, I mean the pin name as same for simplicity. Then I'll save this design. Yeah, no rule violations are there. Then again, I'll go to the test suite. And again, I'll go to the expression and now pick it from the design. So now I can select this IN1. I want to plot this input 1. Then I want to add one more. So I'll click over here to add. Again, go pick from the schematic. Then next I will add input 2. Okay. Again, I'll go to the next. I want to plot output also. So here I'll click on output 2. Okay, sorry for that. Yeah. So all the three are added now. And now I'll click on OK. Fine. So next is we'll go to simulate and click on the netlist and run. Okay. So in few seconds, your design output will come. Your test bench, output waveforms will appear onto the screen. Remember, this is a sequential steps. One by one, we have to go. Yeah. So here is the output. It is coming. Now we have to maximize that. And yeah, let me do that. Yeah. So now it has grouped together. We have to ungroup it. So right click over here, click on ungroup. And that's there we have the output, right? So the red color one is the input 1. The purple color over here is the input 2 and the green is the output. Now basically this is a OR gate. So for a OR gate, whenever in both the inputs are 0, 0, then only the output is 0, else the output is 1. So over here we have 1, 0, output is 1, 1, 1, the output is 1, and then we have 0, 1, the output is 1, and for 0, 0, the output is 0. Again for 1 and 1, 0, the output is 1, 1 and 1, the output is 1, 0, 1, the output is 1, and for 0, 0, the output is 0. So it's perfectly behaving as a two input OR gate. Okay. So the design which we have started, which was building supposed to give a OR gate functionality, it's exactly giving that, right? And then you can save this plot for your further analysis, right? So you can do one more thing. Let me just minimize the screen. You can go to your test suite and go to your simulation. You can check the netlist also. You can display the netlist and click on it. So here is a netlist which is created, the library which we have created, the cell inside the library which we have created, and then this is the spice netlist. As you can see, we are using the sub-circuit, and then inside the symbolic view we are using that symbol, and then we are applying the two pulses, the DC supply and the ground and the capacitor. Okay, so in this way we can simulate and see the results. Let me go and check, show you all again. This way you can build a simple OR gate, AND gate, NOR gate, NAND gates using static CMOS logic in custom compiler in Synopsys, in the Synopsys tool. Okay, so this verifies the functionality of a OR gate, two input OR gate. Fine. So yeah, so that way you all can proceed with your designs. So that's all from my side.